Trigonometry is really important to sailing because you can only sail at a certain angle to the wind. In order to go upwind, you have to tack back and forth to make progress upwind. Woo! Sailboats are most efficient at going upwind at a specific angle to the incoming wind. While at this angle, a sailboat will make its fastest progress upwind, zigzagging back and forth on either side of the wind direction. If you steer your boat at too small of an angle to the incoming wind, you'll be pointing more towards the upwind direction, but going slow. This is called pinching. And if you steer at too large of an angle, you'll move quickly but won't make much upwind progress. This is called footing. To illustrate, let's do an experiment in a controlled environment and see why understanding trigonometry will make you a better sailor. Here at the University of Miami's Rosenstiel School of Marine and Atmospheric Science, scientists use a massive wind and wave tank to study how the air and sea interact. The tank is 6 meters wide, 23 meters long, and using its 1,400 horsepower wind engine, it can create up to Category 5 hurricane force winds. But for our experiment, we only need about 5 knots, the lightest wind the tank can generate, and a really small sailboat. In our test, we'll be using a Dragon Force 65, a radio-controlled sailboat that is 65 centimeters long, 11.6 centimeters wide, has a total sail area of 2,226 square centimeters, and a mass of 1,250 grams. I want to figure out how fast the boat can sail upwind, from one end of the tank to the other, but to do it, I need to understand trigonometry. To figure this out, we're going to sail our boat upwind in the tank over a known distance. Every time the boat reaches a wall, I'll tack, and we'll record how many tacks and how long it takes to get from one end of the tank to the other. We'll repeat the process multiple times and take the average result to make sure our conclusions are accurate.
Starting to feel a little bit of wind.
On average, the boat required 2 tacks to reach the far side of the tank, and about 30 seconds to get there. So now for your challenge. With this information, pause the video now and figure out what angle the model boat sails to the wind. You'll probably need a pencil and paper and a scientific calculator. There are free ones online that work great. Just Google scientific calculator. I figured out 2 ways to reach the answer. The first is based entirely on the geometry of the tank and how many tacks the boat completed. If we assume the boat is always sailing at the same angle to the wind, we can split its course into equal-sized triangles. By knowing 2 sides of each triangle, we can calculate the angle the boat sails relative to the wind. Here I use the tangent function, or the ratio of the opposite side with the adjacent side of the triangle, to reach the solution of 38 degrees. The second way to reach the answer involves time. Since we know the tank is 23 meters long and that it took 30 seconds to reach the far side of the tank, we can quickly calculate the boat's upwind speed of 1.5 knots. We also know that the boat zigzagged back and forth, and using geometry we can figure out that the total distance the boat traveled was 29.4 meters, and that it took 30 seconds, so that the boat's speed through the water was 1.9 knots. Finally, we can draw a triangle that represents the boat's velocity in terms of 2 components, an upwind component, or vector, and a sideways component. Since we know 2 of the 3 sides of the right triangle, we can figure out the angle. Here we used the cosine function and got the same answer of 38 degrees. So next time you go sailing, whether on a big boat or a small one, remember that understanding trigonometry will help you sail smarter and faster. To learn more, visit reach.ussailing.org. US Sailing's REACH initiative, STEM and environmental education through sailing.